Introduction to Arweave. So over the past few weeks, I've been working on some workshops with Arweave and especially around this DataFi concept. And what I wanted to do today is kind of just go through kind of some of the Arweave concepts and give a little bit more background to some of the terminology I'm using in those workshops so that you may have a better understanding. If you're already familiar with the Arweave ecosystem and kind of the components, this workshop may be kind of a 101 for you, but for those that are new to the system, I wanted to try to give you from a developer's point of view what Arweave is, some of the features around Arweave's platform, a little bit about the ecosystem and how the pieces kind of connect, and then a link to some resources to learn more about that. And then I will do like a getting started as a developer workshop video as well. But let's go ahead and just dive in. So, what is Arweave? Arweave is a protocol that allows you to store data permanently, sustainably, with a single upfront fee. So, Arweave focuses on decentralization, security, and scalability. Arweave is different than other kind of blockchain technology. Here's a picture that kind of gives you a difference where you have Bitcoin that each block is kind of a 1 megabyte limit. With Arweave, each block is 2 to the 256 1 byte limit. So that's huge, right? So Arweave allows you to store data on a blockchain type system. We call it the block weave because it is fundamentally different than other blockchains as what has how it stores data. And it does consist of nodes, and those nodes participate in the process of storing data. And instead of kind of the way Bitcoin does it, where it runs like a little um, challenge or puzzle to try to win the ability to write the transaction. Arweave uses a random uh, access point of data in the history of the chain. So that mechanism incentivizes the node runners, the miners, to actually keep as much data as possible because if they can find that random key throughout their history, then they can win the bid to write the transaction and get the reward. At the same time, as each transaction is written, a portion of that goes to a endowment so that basically you can have that pay once mechanism and your data is guaranteed to be stored at a minimum of 200 years. But with this endowment, as it grows over time and as the cost of data decreases over time, it should move to zero, which basically will give you storage forever. And that's why when you hear about Arweave, you hear about this pay once and store forever concept. And having this foundation can really unlock a ton of features. And the features we'll go through basically are trustless, permissionless, and composable. And I think the composability is one of the really most important things because Arweave encourages you as a builder to build in protocols and not in proprietary APIs. The result is composable protocols that the whole kind of community can leverage. So as a result of those kind of principles, we get the following features. The Perma Web, which is basically web servers and web applications served from Arweave. And then we get smart contracts, which are programmable logic that exists on Arweave that can run via clients to basically take an immutable structure like Arweave and create dynamic state within that structure. And we'll talk a little bit more about how that works. Then we have profit sharing tokens and profit sharing communities. These tokens and communities are built because of the way the smart contracts work. And we have atomic NFTs. An atomic NFT is a little different than a normal NFT. A normal NFT, you have a token and you have a digital asset. And many times that token and digital asset exist on two separate networks. And so that kind of creates a problem. So if your token is on a network and your data is stored somewhere else, if something happens to where that data is stored, your token still exists, but it points to either nothing or to something different. And that's not a good effect. So atomic NFTs allow you to have the token and the digital asset share the same identifier, which makes it impossible to break apart. DataFi is this concept that basically takes those four building blocks and puts them in a bundle so that you can kind of work with them, compose them together. So DataFi is kind of the first class kind of thought when you compose these features together to create interesting things. So the first feature is the Perma Web. And the Perma Web is much easier to explain for me than it is to actually work on. So basically, when you write data to Arweave, it kind of goes into a concept of a data lake where basically all the data is stored, but there's not really a lot of structure. It's blocks and then transactions within the blocks. And it's kind of structured as if you would structure data on a hard drive. So you need a way to seek the data and a way to pull the data back in concepts that developers can understand. And that's where this gateway comes into play. And the gateway shapes that data in these transactions. And each transaction has a unique identifier to identify a specific part of data. And then on each transaction, there's one-to-many tags. And these tags can be used to dynamically query groups of transactions. So I can get all the transactions that have an app name public square, or I can get all the transactions that have a content type of plain text. And then you have the actual document data, which exists, and that can have varying links, right? So you could have HTML, images, videos, etc. So this gateway kind of shapes the data almost like a data warehouse, shapes it into this format of transactions. And then in the gateway, we have GraphQL, which allows you to dynamically query those data structures, caching, so that when you query multiple times or pull data multiple times, it's cached at the gateway. So it's not having to go to the Arweave network to pull that document every single time. And then secure socket layers. So you want everything encrypted wire to wire via SSL. And finally, you have these path manifests. And path manifest is a protocol that the gateways understand and allow you to logically route a proper name to a transaction ID. So you may have index.html. So you have arweave.net, then your transaction ID, and then slash index.html. Well, that index.html points to another transaction ID, and the gateway is able to resolve that so the user can type index.html and it would resolve to the transaction ID that actually holds that content. So path manifests act very much like a router on a web server. And with that, you're able to store static websites or single page applications on Arweave. You don't have to store them on a separate web server to run them, which is really cool. Smart contracts. Smart contracts are publicly available source code that can create managed or changeable state on an immutable data store in terms of applying logic. So basically, if you think of how you change data over time on an append-only data structure. So let's say you're doing a counter and your initial state is 0. Instead, you can't edit that state and say now state equals 1. What you have to do is have to create another transaction or another record that says, state now should equal 1, or the function will call and say, I'm going to apply +1 to the state. And then another transactions can execute and write saying, I'm going to apply another +1 to the state. And another one can execute and say, I'm going to apply another +1. So it would be like state is 0, transaction add 1, transaction add 1, transaction add 1. And then when I ask for the state again, I'm going to grab my initial state and all those transactions and replay them in my client to calculate the current state. So I'll replay all those transactions as they were created against this smart contract to calculate what is the current state. And that's how smart contracts work on the Arweave network. They're these lazy loaded executed via your client methods, which result in a new state being performed. And the smart contracts, commonly referred to as warp, they create performance optimizations that increase the ability to read that final state. So you could have thousands of these interactions and be able to calculate the state very quickly. So here's an example of some code in a smart contract. You always have a handle statement, and basically you have a state and an action, and this is a reducer function. So the state is kind of your accumulator, and the action is your value. And when you write an interaction from your app, you're passing in this action, and the state is being read in from all those transactions. So then your function will run, and in this case, change the state name to whatever is passed in as the action input name. Otherwise, if there's no input passed in, it'll say world. And then I've got a reader function that if I call and read, it's just going to return the result of hello and whatever the state.name is set at. If no name is decided, then it's world. So this gives you an idea of how you would, kind of code a smart contract. You have writers and you have readers. A writer will change the state and then return state. A reader will read the state and return a result. And you can do calculations, you can do all kinds of things. So that's smart contracts. Profit sharing tokens or PSTs and profit sharing communities or PSCs are built on top or composed on top of smart contracts. Profit sharing tokens are a simple mechanism built using SmartWeave warp contracts that shares the proceeds of any revenue stream on the Perma Web to its token owners. So if I have an application and that application is going to make revenue by selling NFTs, right? Then profit sharing tokens allows for people that are interested in contributing to that application to have tokens that essentially show their their um, their ability to share in the revenue generated from that application. So if I have 10 units of a PST and someone else has 5 units of a PST and another person has 5 units of a PST, then as revenue comes in for that PST, I would get paid 50% of the time, and the other two would get paid 25% of the time. And so it would all work out to where we're basically in real time breaking down the portion of revenue that's generated from an application. PSCs are a mechanism for developers to express ownership and governance on top of a PST. So if we're an organization and we use a PST to indicate we're members, right? Units of a PST indicate that we're members of that organization. We can lock those units up in a PSC, and that can give us the ability to vote on action items within that organization and make all of those kind of rules kind of fully automated. So if someone votes to add a certain feature to the application, then a vote can be held, and all the PST unit holders that have staked their tokens for a duration can act on their vote, and that stake will give them the weight of the outcome, right? So if I have 10 units and I stake 5, and someone else has 5 units and they stake 5, then our votes are equal. But if I stake 10 and they stake 5, then my vote weighs a little bit more than the other person's vote. Hopefully that makes sense. I'm still learning these concepts, so if there's clarifications, please let me know. But essentially, a PST represents a unit that can be used to share revenue or profit, and then a PSC represents a community which can have governance over an organization, and it could be one to many PSTs. Atomic NFTs. So I want you to visualize this outside box as being one transaction on Arweave. And that one transaction has an ID. Every transaction in Arweave has to have an ID. In that transaction, an atomic NFT contains a digital asset, which is the actual data. Could be an image, could be a Permaweb app, could be any kind of entity of data. Then you have a contract that's attached to that can return a balance from a wallet and then also transfer the ownership of this NFT from the owner to a target, a requester. And then you have kind of the initial state, and the initial state has several attributes that we can get to in the Atomic NFT workshop, which will be included in the notes. And then finally, you have the tags that we discussed over when we were talking about the Perma Web, and you can add those tags within the atomic NFT to make it easy to locate or query the NFT or batches of NFTs. So that's the atomic NFT. And then finally, we have DataFi. And DataFi is this concept of combining the permanent data, the NFT, the Perma Web, the smart contracts, and the PSTs in ways that provide decentralized finalization features for immutable storage in Arweave. And that's simply to say that we can take all of these technologies and create some really neat use cases that can allow us to build applications that you just can't build anywhere else. So that's what's really exciting about Arweave is that it starts with this very simple base layer that you can store any kind of data forever. And then you can build these abstractions that compose on top of it to create very sophisticated and frankly novel kind of applications and approaches to applications that we haven't seen. Still, it's super early in the ecosystem, but it is a lot of fun. And I think there's a lot of opportunity to create some really cool stuff. Now, I've talked about many pieces of the ecosystem, but the one I haven't is this bundler network. Bundler network is a layer 2 protocol that runs on top of Arweave, and it's really bringing Arweave to this completion of the blockchain trilemma, right? So the blockchain trilemma is you have decentralization, security, and scalability, and you pick two. Now, when you take Arweave, when you pick two, you're picking decentralization and security. But how do we get scalability? And that's where the bundler network comes into play. It allows us to bundle multiple transactions within a transaction within a block. So as the Arweave flow every 2 minutes, minting a new block goes about its business. Within those blocks are transactions. Bundler allows us to stuff many transactions in each transaction of that core transaction block. Therefore, gives us the ability to write many transactions, many more than we could without that technology on the main Arweave blockchain, therefore closing this trilemma, giving us scalability by bundling multiple transactions in this layer 2, updating the cache so that they're immediately findable, and then publishing them through a normal blockchain workflow, which is pretty cool. There are also many more players in the ecosystem. If you go to view block Arweave ecosystem, there's just too many to count, but you can check out all the players here, and there's even more. Yeah, the space is growing like crazy, and there's a lot of cool stuff to check out. Digital wallets. So there's 3 digital wallets on the platform. There may be more, but there's 3 that I'm aware of. Arweave.app is a browser wallet. It actually runs in the browser side by side with your app and connects to it via iframes. So the neat thing about Arweave.app is you can actually run it on mobile and connect. It's still, there's a little bit of, nudging you have to do, but it does work on mobile, which is really cool. And then there's Rconnect, which is probably the most popular wallet in Arweave, and that runs as a browser extension. So you go and install it into your browser, and then when you're going to a decentralized app, hit connect, it will pop up and allow you to log in via the browser extension. And then Finny especially for the coin network, which it specializes in NFTs and attention tracking, has a wallet that works very similar to Rconnect. It's a browser extension that you install, but they are also working on a mobile version that I think they're releasing soon, which should be pretty cool to check out as well. Um, if you want to get an idea how all these pieces work together, I recommend you check out Permanutes App. It's um, an app that I'm working on that really focuses on making notes available forever. And I guess I can do a quick demo. So when you go there, you connect with your favorite wallet. Um, and if you don't have a wallet, it's pretty easy to create. Then you log in, and I'm going to disconnect and log in with kind of a newer account. Um, and you get your profile page. And if you want to create a profile, you can go to Arweave account and create a profile. And then you have your notes, your favorites, and a new note. So you can create a new note. And the neat thing about it is if you leave the note marked as private, it will encrypt end to end. So that means you will only be able to read that note with your wallet. Anybody else will not be able to read it. Or you can mark it public and post it for the whole world to see, which is pretty cool. And it just uses simple markdown to create your note. And it's a lot of fun. So I ask you to check it out. It's completely on Arweave, right? So the front end, the back end, the smart contracts, all of that is on Arweave, which is super cool. That means it will be here forever. And it doesn't cost anything to create a note. You just have to have a wallet, and then you can create as many notes as you want, as long as they're under 100K in size, which you would have to write a lot to be bigger than 100K. So yeah, check that out. And with that, I'll leave you with resources. So where can you get started with Arweave? There's Rwiki. There's OnlyArweave, which is a great place to get started and has a lot of information about the community, the ecosystem, etc. And if you're interested, I'd ask you to check out some more of these videos on hyper videos. There's a bunch of workshops on Arweave, and yeah, try to keep them around 30 minutes. But I think you can learn how to do a lot of stuff. And that's it. Hopefully, you learned a little bit about kind of some of the buzzwords in the Arweave community system. And if you have any questions, please leave a comment. Happy to answer anything. And also, the Arweave Dev Discord is great too. And I'll leave that in the show notes as well.